Hi, I'm Jigar Patel, and today I'm going to present Project 2. So, this is a Jupyter notebook for Project 2, and let's import the libraries. And I took the sample rate as a default at 100 and the sampling period of 1 divided by fs, and the timing range is -4 to 4, and alpha is 0.5, that's default alpha. So for the task 1, I plot the different value of alpha from 0 to 1 at the increment of 0.1. So let's run this code, and it's throwing some warning related to version, so I think nothing to worry about this, as I'm doing all 10 increments, so it might be taking a little bit longer. And let's look at the graph here. Yep, so as you can see here, as the alpha, this dark blue line is the alpha 0, so that's that has a highest fastest transition from high value to the low value, and this uh, light blue line is the slowest transition from low high to low value. And so this light blue line is alpha is equal to 0.9, and this dark blue line is alpha is equal to 0.1. And there is, as you can see, as the alpha is increasing, the transition time is increasing. And on the frequency domain, so this is a sync pulse, so amplitude for all the values, all the alpha values is same, but the um, sync pulses are died down slowly with this dark blue signal. So that's with the alpha is equal to 0.1. So with the highest alpha, sorry, with this low value of the alpha, it takes longer time to die down, so it has a longer or wider bandwidth. And with the higher value of the alpha, the if you see that this is the lowest highest value of the alpha 0.9, so the amplitude of this signal is very low. So as the alpha is increasing, the bandwidth is narrowing. So that's inverse of in the time domain. So as the and for the task 2, these are the different bit value. So I took the different bit value here. For example, I took the bit value -4 to 4, but let's go with the standard bit value that's mentioned into the project: -3, -1, 1, and 3. So I'm running with the same bit values and adding the default noise level as a 0. And these are the different signals. So if you see, there's bit value is from 1, -1, and so as you can see, there is multiple the different level of 1, 3, -3, and -1. And you can see the similar level here in the signal. So 3, so most of some signals are at 3, some signals at 1, -1, and -3. Let's turn to the next step. Okay, so it's still executing. Let's wait for a second. Yep, so we have 4 signal level, and that's why there's 4 eyes, and as there is no noise, so this looks very clean. And you can see the transition at 3, 1, -1, and 3. So those are the 4 signal level we choose, and the 4 signal level is making three eyes. So now if we increase the noise level, so you can see the effect of the noise level on the eye. So let's increase the noise level here. Let me remove this printing the bit value, and I'm increasing the noise level a little bit, 2.1, and run it. And as we run it, and this is going up, this is still executing. You can see it here. Okay, so now with this more noise level, you can see some signals that's more distorted, and this eye is, you can see clearly from in the eye, the transition is not smooth between at -3, 1 and 0. Oh, sorry, -1 and -3, so its transition is not clear. And we can also observe the sum of the signal. So let's change the signal noise level to 2.2 and run it again. So you can see the different level with the noise, with higher noise. You can see there's wider transition here, and you can clearly observe more noise compared to 0.1 noise. And let's change noise further to higher level, 0.5. So we are expecting a lot of noise. Maybe the eye may not be visible here. Let's see. Okay, with the higher noise, it's barely we can see 3 eyes, and so this signal may not be demodulated. So we can also see clear transition. Let's see, we can go back to the lower noise level and only show certain pulses. So instead of printing all bits, we can just print the 10 bits and observe how it looks like. Yep, so here you can let me show the bit value. Yep, so here it's 3. So first bit is going up 3, then -3, so you can see a little bit longer duration going down, and then 1 going slowly up, 3 3, and then 1 -1 3 and 1. So you can clearly relate this bit value to the pulse signal, and also we can observe the noise. So we can increase the noise. You can see there's smaller effect of the noise on the signal, and with higher noise there's too much noise. But as we shift all the bit value and make the eyes, so when we make the eye, there's because of all this noise interpolate with each other and making this eye almost very it's closed eye, and that indicates lot of noise into the system. So this is my observation from project 2. Thank you.